So far, all of the trig that we have done has been connected to right triangles. We started with right triangles, then we moved on to not right triangles, but everything's been connected to triangles, okay? So what we're gonna start looking at today is what happens when you take the triangle out of the problem and just start talking about the angles. Okay, so we're gonna start talking about just these different angles, and we're gonna talk about how we measure angles and a few different things like that. So the first thing we're going to talk about is how do you draw angles in standard position. This isn't particularly difficult, but it does sometimes take a little bit of adjusting just because it's different, okay? So the first thing that you need to know is that whenever you draw an angle in standard position, your vertex is always at the origin, okay? So 0, 0. We're going to draw a little baby coordinate plane. Your vertex is going to go at the origin. The starting edge of your angle, right? There's two edges on your angle. The starting edge is always going to be on the positive x-axis. All right, and then this next part is a little bit counterintuitive. So you would assume that a positive angle would move clockwise and a negative angle would move counterclockwise. It's actually backwards. Okay, so positive angles go counterclockwise, and then negative angles are going to go clockwise. Okay, so let's start out with a 240-degree angle, and I'll show you what I mean. Okay, so when we go to do this, I'm going to start by drawing just a little baby coordinate plane. I'm not going to put any numbers or anything on here. We don't need to do tick marks or anything. It's just a general coordinate plane. All right, and we're going to start with our vertex at the origin. So I'm putting a point here at my origin. Come on, marker. There we go. Okay, so there's my vertex. And then my starting edge always has to be on the positive x-axis. Okay, so there's my starting edge. All right, now we are going to rotate because this is a positive number. We're going to go counterclockwise. So that means this way, right? And I need to move 240 degrees in that direction. So if I'm starting here, this would be 0 degrees, right? Which means that up here, that would be a 90-degree angle. And then over here would be a 180-degree angle. Come on, marker. There we go. And then down here, that's another 90 degrees. So that would bring me up to 270. And then if I kept going another 90 degrees, that would bring me to a full circle of 360 degrees. So you can see that this side here could represent either 0 degrees or 360 degrees. Okay, but we don't need that right now. We need 240. So what I'm going to do is I'm going to say, all right, 240 degrees, that's going to fall between 180 and 270. All right, and let's see, that's about 60 degrees more than 180 and about 30 degrees less than 270. So it's going to be between these two, but closer to 270. So I'm going to draw my line here between these two, but closer to 270. Okay, it doesn't have to be super, super exact. You don't need to get out a protractor and measure it. You're just going to give it like a good estimate of where it's going to go. All right, but there's one more thing that we need to do here, because remember we said positive angles go counterclockwise and negative go clockwise? Well, looking at this picture, you couldn't tell whether I had gone in the positive direction to get here or if I'd gone in the negative direction to get here. So the last thing that we're going to do is we're just going to draw a little arrow that shows the way that we spun our angle. So I'm starting here on my positive x-axis, and I'm just drawing a little arc, a little curvy arrow that shows what direction we went in. So we went this direction. Okay, and that's what my angle is going to look like. All right, great. So next up, let's try, how about a 500-degree angle? Okay, so a 500-degree angle. Here's my coordinate plane. All right, I know that my vertex is always here, and my starting side is always on the x-axis, the positive side. All right, I need 500 degrees. So here's 0, here's 90, another 90, this would get me to 180, another 90, that'd be 270 down here. Another 90 would get me to 360. Well, that's great, but I need 500, so I'm not there yet. So what's going to happen here is we're actually going to go all the way around the circle and then do extra. Okay, so if I kept going, if I went all the way around the circle to get to 360, and then I went farther, another 90 degrees, that would land me at 450 degrees. and then another 90 degrees, that would land me at 540 degrees. And this 500 I need is going to fall between these two. Okay, so when I look at this, I'm going to say, all right, 500, well, it's 50 away from here and 40 away from here. So that's going to be almost the middle, but slightly towards 540. Again, it doesn't have to be perfect, it's just kind of close. And then when we draw our arrow, my arrow is not just going to go to here because I did a full loop of the circle, and you need to be able to show that. I need to make it obvious from my drawing that I'm not talking about an angle between 90 and 180. I'm talking about one between 450 and 540. So I'm going to draw my angle from my starting line. I went all the way around the circle, and then I went a little bit more. Okay, so it kind of looks like a snail, right? A snail shell that kind of spirals. And that's what that's going to look like. All right, great. So then the last angle that we're going to do is let's talk about what happens when you have a negative angle. Okay, so let's talk about what happens when you have a negative angle. So let's see. For our negative angle, let's do, how about, negative, let's do a negative 75. Sorry, I had written down which angle I wanted to do. And then my computer restarted randomly in the middle of this, so I couldn't just take a look at which angle I was planning to do because it's gone now. All right, so here's my coordinate plane. We're going to do a negative 75 degree angle. So here's what's going to be the same. I'm still starting with my origin at the vertex at the origin. Okay, my starting side is still here. It's called the initial side. That's the technical word for it. All right, and then this is still going to be 0 degrees, but since I'm looking for a negative angle now, I'm spinning the opposite direction. So instead of this being 90 degrees up here, I'm going to spin clockwise. So this is where negative 90 is going to go. Okay, over here would be negative 180. And then up here would be negative 270. And negative 360 would be over here. Okay, so notice that they go opposite. So positive 90 was up here, negative 90 is down here. Okay, now I want negative 75. So negative 75, that's going to be in here, closer to 90 than to 0. So I'm going to draw my terminal side. And then my arrow is going to go for my starting side, showing that I swung regular clockwise for that one. Okay, so that is how you draw angles. Pretty easy. All right, now you're going to notice that we've been talking only about degrees here, and you've probably only ever looked at degrees as a measurement of angles. Okay, but there are other ways that you can measure angles, one of which is called radians. Okay, so we're going to talk about radian measure today. All right, and this is similar to the same way that we can talk about measuring something in feet or yards or miles, right? It's the same thing. You're just using different units, so they end up with different numbers assigned to them, basically. Okay, well, radian measures is the same thing as doing degrees. It's just a different type of measurement. Okay, so they're not the same in the same way that feet and miles aren't the same, or that feet and yards aren't the same, but they both measure the same thing. Okay, feet and yards measure a distance, radians and degrees measure angles. Okay, so we talk about radians. So the first thing is, what the heck is a radian? Okay, so what a radian is, 1 radian is the measure of the angle with an intercepting arc. So an intercepting arc of length radius. Okay, so it's the measure of the angle with intercepting arc of length radius. And you're probably thinking to yourself, the heck is she talking about? Okay, so what I'm going to do is I'm going to switch over really quick to a GIF that I think is going to help you figure this out. The first time, I want you to just watch the GIF and just see, okay, well, what happens? And then I'll kind of narrate you through it. Okay, so that's the idea of where radians come from. All right, we're going to do it one more time, and I'm going to kind of talk you through it. Okay, so we're starting by just making a circle. That's the radius of my circle, that red line. Okay, so that's my radius. And then what we're doing is we're saying measure a chunk of the circle that's the same length as the radius. Okay, so that arc is the same length as the radius. And the angle that it makes, that's what a radian is. Okay, so that's 1 radian. There's 2 radians. There's 3 radians. And if you go halfway across, that's pi radians, 3.14 radians. So half the circle is going to be pi radians. So then the full circle would be 2 pi radians. Okay, so this is what the measure of a radian is. So let's do that one more time. So we're going to start by making a circle with a radius of that red line. Okay, so that's my radius. Now I'm measuring an arc of the circle that's the same length as the radius. Okay, and the angle that that makes, that is what a radian is. Okay, so that's what a radian is. 2 radians, 3 radians, and half a circle is pi radians. That's going to be an important thing to remember. And then the entire circle is 2 pi radians. Right? If half of it's 1 pi, the whole thing's 2 pi. Okay, so all that these radians are is it's just a different way of measuring an angle. When we measure in degrees, it's just that we took a circle and we split it up into 360 little tiny pieces, which has to do with Babylonians and the fact that they worked in a base 6 number system, and it ties in with all of that. So this is something that's not tied into the fact that some random old civilization decided that there was going to be 360 measurements. It's just tied into the geometry of how a circle works. So you look at the arc that's made when you measure 1 radius. So you measure an arc that's 1 radius long, the angle it connects with. That's what a radian is. And again, you need to know that half of a circle is pi radians and the full circle is 2 pi radians. Okay, so now that we've kind of looked at what a radian is, let's talk about them a little bit more. So as we kind of saw from that illustration, 180 degrees is the same thing as pi radians. Okay, so 180 degrees is equal to pi radians. Just like how we say 3 feet is equal to 1 yard, same thing. Okay, and then similarly, 360 degrees is equal to 2 pi radians. Okay, so we've got kind of those two things to use as our basis. So let's take a look at how we are going to draw these, okay? So the first thing that we're going to look at is let's look at, say, pi over 2 radians. So pi over 2, all right? And I'm going to draw my coordinate plane. We're going to start this out the same way that we did the last ones. So my origin's still at the vertex. My vertex is still at the origin. I keep saying that backwards. Vertex is still at the origin, and my starting line is here. Okay, now we need to go through and label what all these different spots are, just like how we did before. But the difference is that now we're kind of dealing in fractions here. This is like 1 pi over 2 or a half pi. So when we're going to label these, I want to be kind of strategic in how I'm going to label these, okay? My denominator here is halves, okay? And I know that over here, this is the same thing as pi radians, right? So I could write over here that this is pi radians, but here's what I'm going to do. Since my denominator is 2, instead of just labeling that as pi, I'm going to label it as 2 pi over 2. Okay, well, 2 pi over 2, that simplifies to just 1 pi, right? That's the same thing as pi. But what it does is it gives me a common denominator here. Okay, and that's going to be really useful because this over here, I could write this as 0, but I could also write it as 0 pi over 2, right? That's the same thing. And it's got a common denominator with this. So where this guy is 1 pi over 2, and I'm trying to find that, I can sort of look at this and say, all right, well, now I've got a basis point. If this is 0 pi over 2, and this is 2 pi over 2, and this is halfway between them, well, halfway between 0 and 2 is 1, right? So this guy up here is going to be 1 pi over 2. All right, and then that's convenient because now I know that this 190-degree angle, right, that's the same as going, if I'm going from 0 pi over 2 to 1 pi over 2, that tells me that 90 degrees is just 1 pi over 2. So to go from here to here, I'm just going to add 1 pi over 2. I've got 2 pi's over 2. I'm adding 1 pi over 2. That means this is going to be 3 pi over 2. And when I add another one to get from here to here, that's going to be 4 pi over 2. And that makes sense because I know 360 degrees should equal 2 pi's. And 4 over 2, that simplifies to 2, right? All right, and then that lets me figure out pretty easily where's my 1 pi over 2. That was actually the same as a 90-degree angle. So that's going to go here, and there's my angle. Okay, so we're using this common denominator thing to help us out. Okay, so next one, let's do 5 pi over 6. All right, and we'll see where this guy's going to go. Okay, so here's my little coordinate plane. I'm still putting my vertex at the origin, still starting the positive x-axis. All right, now last time my denominator was 2, so I did everything in terms of 2's. Now my denominator is 6, so I want to write everything in terms of 6 denominators. Okay, so I know that this guy is going to be 0 pi over 6, right? Because that's always 0. And then over here, since this has to simplify to 1 pi, I can write that as 6 pi over 6. Okay, and you can sort of see the commonality there, right? These ones are zeros, and these ones, it's the same number top and bottom, so it simplifies to 1. Okay, and then once I have that, halfway between 0 and 6 is 3, right? So that tells me that up here is going to be 3 pi over 6. And then once I know that, that means that I know that this 90-degree turn is 3 pi's, right? It's 3 pi's over 6. So 3, 6, down here is going to be 9 pi over 6. And if I went 3 more, 3, 6, 9, 12, this would be 12 pi over 6. Again, I know that simplifies to 2, so I know I'm doing it right. So when I want to find 5 pi over 6, the angle that I'm looking for, well, here's 3 pi over 6, here's 6 pi over 6. So 5 pi over 6 is going to be between the two of these, closer to 6 than it is to 3. Okay, and then I'm going to draw my arrow. All right, and then last one, let's do 21 pi over 8. Okay, because this one's going to be a big one. So 21 pi over 8. Okay, here's my coordinate plane. Just like before, my vertex is going to go at the origin. Here's my starting line. Okay, I know that this guy is the same as 0 pi over 8. Again, I'm using that common denominator of 8. Over here, that's going to be the same as 8 pi over 8. Okay, and then halfway between 0 and 8 is 4, right? So this guy up here is going to be 4 pi over 8. And then that tells me what each 90-degree turn is. So each 90 degrees gives me an extra 4 pi over 8. So this was 4 pi over 8, 8 pi over 8, 16 pi over 8. So then this would be 20 pi over 8. This guy would be 24 pi over 8. Right? I'm just basically counting by 4s in the numerators, right? Okay, so when I want 21 pi over 8, I know that's going to be between 20 and 24, closer to 20. So that's going to be somewhere down here. And just like we did before with our degree angles, I just need to show that I looped the whole circle and then went a little bit extra. So I started here, I looped the whole circle, and then went a little bit extra. All right. Now, if you were going to do a negative radian angle, you would do the same thing, except turn the opposite way. Okay? So that is how you are going to graph angles that don't have triangles. Okay, and that's kind of your introduction to radian angles. You're going to need to be able to work with either degrees or radians for the rest of this unit.